Namaskar. As teachers, we often make decisions based on intuition or anecdotal evidence. But what if we could use data to inform our decisions and improve students' outcome? Statistics can help us to do just that. In this video, we'll discuss the fundamentals of statistics and how to apply them in the classroom. But before we begin our topic, let us focus on the book Mathematics Textbook for Class 10th by NCERT. Dear facilitators, we can start our topic by asking some questions to check their previous knowledge about statistics, like what is the meaning of statistics? After getting the various replies from the students, we can explain them about the meaning of statistics. Every day we come across a lot of information in the form of facts, numerical figures, tables, graphs, etc. These are provided by various sources like newspaper, magazine, television, and other means of communication. It may be, for example, related to cricket scores, profits of a company, temperature changes, etc. These facts or figures, which are numerical or otherwise collected with a definite purpose, is called data. The extraction of meaningful information from these data is called statistics. Thus, statistics deals with collection, organization, analysis, and interpretation of the data. The next question that comes is how we can represent data. We can tell our students that they have studied the classification of data into ungrouped and grouped frequency distribution. They have also studied how to represent data pictorially in the form of bar graphs, histogram including those of varying widths, and frequency polygons. Next, the question arises, do we need to study all the data to make sense of it? Or we can make out certain special features of it by considering certain representation of the data. In fact, we went a step further by studying certain numerical representative of the ungrouped data, also called as measure of central tendency, namely mean, median, and mode. In this video, we'll extend the study of these three measures from the ungrouped data to that of the grouped data. Then we can explain them the three measures of central tendency for the grouped data one by one. Let us first begin by explaining about the arithmetic mean. We can tell our students that there are three methods of finding the mean. We can find the mean by using direct method, assumed mean method, and step deviation method. Let us first understand mean by direct method by taking an example. Here we have marks obtained by 30 students of class 10th of a certain school in a mathematics paper consisting of 100 marks, which are presented in the table below. And we have to find the mean marks obtained by the students. Now for each class interval, we require a point which would serve as a representative of the whole class. It is assumed that the frequency of each class interval is centered around its midpoint. So, the midpoint or class mark of each class can be chosen to represent the observations falling in the class. To find the class mark, we use the following formula. Class mark equals to upper class limit plus lower class limit divided by 2. So, for the first class interval, class mark can be as class mark equals to 10 plus 25 divided by 2, which gives us the value of class mark as 17.5. Similarly, we can find all the class marks and we get the values as After finding the class marks, the next step is to find the product of FIs, that is frequencies, and the corresponding XIs, that is class marks. and we can get the values as shown in the table. After finding the product of frequencies and class mark, the next step is to find the mean. For this, we use the formula mean is equal to summation fi xi divided by summation fi. Here, summation means sum of the specific values. In this case, we find the sum of all the frequencies and sum of fi xi column. So now mean is equal to summation fi xi divided by summation fi, which equals 1860 divided by 30, and we get the value of mean as 62. Sometimes when the numerical values of fi's and xi's are large, then finding the product of fi and xi becomes difficult and time consuming. For such situations, we can use another method which can reduce these calculations. The method used is assumed mean method. For understanding this method, let us take the same example which we have taken earlier. The first step is to choose one among the xi's as the assumed mean and denote it by A. Also, to further reduce our calculation work, we may take A to be that xi which lies in the center of class marks, that is from x1 to xn. So, we can choose A equals to 47.5 or A equals to 62.5. Let us choose A equals to 62.5. The next step is to find the difference di between A and each of the xi's, that is, the deviation of A from each of the xi's. That is, di equals to xi minus A, which is equals to xi minus 62.5. After finding all the di's, we get the table as. The third step is to find the product of di with the corresponding fi and take the sum of all the fi di's. The calculations are shown in the table below. The formula to find the mean using this method is x bar equals to A plus summation fi di divided by summation fi. So after substituting the values, we have x bar equals to 62.5 plus minus 15 divided by 30. X bar equals to 62.5 plus minus 0.5, which gives the value of mean as equal to 62. Further, we can use another method to find mean, which is called as step-deviation method, which can further reduce the calculations. Let us see how it can be done. For this, once again, we take the same question which we have taken earlier. As we can see that we already have the deviations in this table. Here, we will introduce another variable ui. Let us see how this can be calculated. We take the value of ui as follows. Ui equals to xi minus A divided by H. Here, H represents the class size, which is 15 in this question. A is assumed mean, which we have taken as 62.5. Now, for the first class interval, that is from 10 to 25, UI will be as UI equals to 17.5 minus 62.5 divided by 15, which gives us the value as minus 3. In this way, we can calculate UI for the remaining intervals and we get the table as next step is to find the product of Fi and the respective UI and get the values of Fi UIs. After finding the values, we take the sum of FIs and Fi UIs columns and we will get the final table as the formula to find the mean using this method is x bar equals to A plus summation Fi UI divided by summation Fi multiplied by H, which gives x bar equals to 62.5 plus minus 1 divided by 30 multiplied by 15. X bar equals to 62.5 minus 0.5 and which gives the result of mean as 62. So, dear teachers, we can tell our students whichever method we use to find the mean, the value of the mean will remain same in each method. Let us take another question to understand about step deviation method more clearly. Here we have a distribution of daily wages of 50 workers of a factory. And we have to find the mean daily wages of the workers of the factory by using an appropriate method. Here, since the class intervals are large, so step deviation method can reduce our calculations. The first step would be to find the class marks for each interval. After that, we find the DIs, also called deviations, by the formula xi minus a. In this question, we have taken a, that is assumed mean, as 550. After finding the values of di, the next thing we find ui, which can be found by dividing di by h, which is the class size, and in this case, the class size is 20. And then finally, we find fi ui. So finally, we find the mean for this question using the formula mean equals to a plus summation fi ui divided by summation fi into h. So after substituting the values of all, we finally get the mean as 545.2. The next measure of certain redundancy is mode. We should ask our students to recall about mode from their previous class. A mode is that value among the observations which occurs most often. That is, the value of the observation having the maximum frequency. Further, we also discussed finding the mode of ungrouped data. Here, we shall discuss ways of obtaining a mode of group data. It is possible that more than one value may have the same maximum frequency. In such situations, the data is said to be multimodal. Though group data can also be multimodal, we shall restrict ourselves to problems having a single mode only. Let us understand about mode with the help of an example. A survey conducted on 20 households in a locality by a group of students resulted in the following frequency table for the number of family members in a household. Let us find the mode of this data. The first step in finding the mode is to find the model class. Model class equals to class with the highest frequency. The mode is a value inside the model class and is given by the formula mode equals to L plus inside the bracket F1 minus F0 divided by 2F1 minus F0 minus F2 bracket closed multiplied by H, where L equals to lower limit of the model class, H equals to size of the class interval. So we are assuming that all class sizes to be equal. F1 is the frequency of the model class, F0 is the frequency of the class preceding the model class, and F2 is frequency of the class succeeding the model class. Now, for the given question, model class is from 3 to 5. So, value of L equals to 3, F1 equals to 8, F0 equals to 7, F2 equals to 2, and H equals to 2. So, by substituting the values in the formula, we have mode equals to 3 plus inside the bracket 8 minus 7 divided by 2 times 8 minus 7 minus 2 and the whole multiplied by 2. So, mode equals to 3 plus 2 by 7, which gives us the value of mode as 3.286. The next and the last measure of central tendency is median. Dear teachers, we can ask our students that what they know about median. After getting the responses, we can explain them about median of the ungrouped data depends upon the number of observation, which means when the number of observation n is odd, the median is the value of n plus 1 upon 2th observation, and when the number of observation n is even, the median is the mean of n upon 2th and n by 2 plus 1 observation. To find the median, we will have to first understand about cumulative frequency. Let us understand it with the help of an example. Consider a group frequency distribution of marks obtained out of 100 by 53 students in a certain examination as follows. After showing this table to students, we can ask some questions from students as how many students have scored marks less than 10? The answer is clearly 5. The next question we can ask them is how many students have scored less than 20 marks? Observe that the number of students who have scored less than 20 include the number of students who have scored marks from 0 to 10 as well as the number of students who have scored marks from 10 to 20. So, the total number of students with marks less than 20 is 5 plus 3, that is 8. We say that the cumulative frequency of the class from 10 to 20 is 8. Similarly, we can compute the cumulative frequencies of the other classes, that is, the number of students with marks less than 30, less than 40, and so on till less than 100. The distribution given here is called the cumulative frequency distribution of the less than type. Here, 10, 20, 30 up to 100 are the upper limits of the respective class intervals. We can similarly make the table for the number of students with scores more than or equal to 0, more than or equal to 10, more than or equal to 20, and so on. Then the distribution will be called as the cumulative frequency distribution of the more than type. But here, for finding the median, we are considering the cumulative frequency distribution of the less than type only. Let us understand how we can find the median. This is the complete table after finding the cumulative frequencies of each interval. So, for finding the median, the first step is to find the median class from the table. Now, median class equals to class whose cumulative frequency is greater than and nearest to n by 2. Here, n equals to total number of observations, that is, total of frequencies. So, in this case, n by 2 is equal to 26.5. Therefore, median class is from 60 to 70. After finding the median class, we use the following formula for calculating the median. So median equals to L plus, inside the bracket it's n by 2 minus Cf divided by F, and the whole is multiplied by H, where L equals to lower limit of median class, N equals to number of observation, Cf is cumulative frequency of class preceding the median class, F is frequency of median class, and H is class size. We assume that class size to be equal. So, after substituting the values in the given formula, we finally get the value of median as 66.4. So, about half the students have scored marks less than 66.4 and the other half have scored marks more than 66.4. Dear teachers, after explaining all about the three measures of central tendency, we should discuss which measure of central tendency would be best suited for a particular requirement. The mean is the most frequently used measure of central tendency because it takes into account all the observations and lies between the extremes, that is, the largest and the smallest observation of the entire data. It also enables us to compare two or more distribution. For example, by comparing the average results of students of different schools of a particular examination, we can conclude which school has a better performance. However, extreme values in the data affect the mean. For example, the mean of classes having frequencies more or less than the same is a good representative of the data. But what if one class has frequency, say 2, and the other 5 have frequencies 20, 25, 20, 21, 18. Then the mean will certainly not reflect the way the data behaves. So in such cases, the mean is not a good representative of the data. In problems where individual observations are not important and we wish to find out a typical observation, the median is more appropriate. Example, finding the typical productivity rate of workers, average wage in a country, etc. These are situations where extreme values may be there. So, rather than the mean, we take the median as a better measure of central tendency. In situations which require establishing the most frequent value or most popular item, the mode is the best choice. Example, to find the most popular TV program being watched, the consumer item in greatest demand, the color of the vehicle used by most of the people, etc. There is also an empirical relationship between the three measures of central tendency. 3 median equals to mode plus 2 times mean. Here are some teaching strategies which we can use for better understanding of the concept to the students. These are some of the common mistakes which can be avoided while doing statistics. We can use various assessment tools for assessing our students. Here are some of the tools which I have shared. Few of the activities are also shared here. You can also choose any of the activities of your choice also. These are some suggestive ways of teaching statistics which may be executed to teach each specific topic of statistics. By following this, we will be able to complete our topic in a stipulated time and can also take queries from the students. We may also assess our students' level of understanding in the given time period. With this, I would like to conclude our today's topic. Namaskar.